Hi, I'm Cameron Rogero, and my presentation will go over blockchain and the cybersecurity of cryptocurrency. So, what exactly is cryptocurrency? Well, it's a medium of exchange, just like normal money, but it's created and stored electronically in what's known as blockchain. So, it actually has no intrinsic value like something like gold or silver. It has no physical form, so it exists only in the network, and this network, like I previously said, was blockchain. And it's completely decentralized. So there's not one company or host that controls the asset. And in circulation right now, as of April 2020, there are approximately 5,392 cryptocurrencies. And this has a total market cap of $201 billion. So a very large amount. Some of the top coins, including cryptocurrency, are Bitcoin, Ethereum, and XRP. So these make up a large majority of the cryptocurrency market. So this brings us to our second topic, which is blockchain. So blockchain is a specific type of database that differs from a typical database in the way that it stores information. So blockchains store data in blocks that are chained together. So exactly what its name sounds like. And this creates a sort of ledger to record every transaction between people that are trading cryptocurrency. So whether you're buying it, selling it, blockchain is a form of bookkeeping that's happening that's similar to what's in the financial world. Basically, each one of these blocks has certain characteristics and rules that it has to follow. And I'm going to be going more in depth on that in some of the next slides. But each blockchain is 1 megabyte of data, and the average transaction is around 500 bytes. So there are roughly 2,000 transactions per block. There are situations where one transaction can encompass nearly an entire block, but those are rare, and those are very large transactions that are happening. Each one of these blocks gives a certain amount of Bitcoin, and the number of Bitcoin per block decreases roughly every 4 years, and this is known as halving. So if you ever heard about Bitcoin halving, this is what it's referring to. So in 2009, you could get 50 Bitcoin per block, and then about 4 years later, it went down to 25, sorry, then 12.5, and now it's at 6.25. And a few years from now, it's going to go on to 3.125, and so on. But basically, let's go through how a blockchain transaction works. And this is a great diagram that shows what's happening. So someone will request a transaction, whether they want to buy or sell it. And this transaction will be broadcast to a peer-to-peer network of computers. And this network will validate the transaction using known algorithms. So this is related to Bitcoin mining, which I'm going over in the next slide. Then the verified transaction will add the block to the existing blockchain. Once that block is validated and added, the transaction will be completed. Bitcoin mining is a way for people to earn Bitcoin as a reward for completing blocks of verified transactions. So these blocks will contain public keys that are addresses which people who have the Bitcoin, basically where they claim to have received it from originally. Once these blocks are verified by the Bitcoin miners, they will be added to the end of the blockchain, and they'll receive a certain amount of Bitcoin as a reward. And so there's roughly 18.6 million Bitcoin in circulation right now, and that will be capped at 21 million. But the last Bitcoin isn't set to be mined until around 2040, and that relates to the Bitcoin halving that I talked about before. So in order to set up one of these mining rigs, you need either a GPU or an application-specific integrated circuit. And these can cost anywhere from a couple $1,000s to tens of thousands of dollars, or even if you're a big company, hundreds of thousands of dollars. In order to verify one of these blocks, you need to complete a complex hashing puzzle. Each hash on the block consists of a 64 hexadecimal number. Basically, what the miners are trying to do is guess a value equal to or less than the hash that's on the block. If they are the first to do that, then they will receive Bitcoin as a reward. Since there are thousands of people that are trying to guess this hash, on average, there's about 2.4 quadrillion hashes that are created per Bitcoin mined. So you can see how that's an extreme amount of computing power. These hashes have specific rules, so they need to have at least 8 zeros in the beginning and up to 63 zeros. And these Bitcoin miners aren't actually guessing the 64-digit hexadecimal number directly. They're using 32-bit guesses called nonces that are converted into the hashes through known complex cryptographic algorithms. So like I said, if they're the first to do it and they guess a value equal to or less than the hash on the block will be verified, added, and they'll receive a certain amount of Bitcoin as a reward. Why is blockchain so valuable? Well, in Bitcoin's case, blockchain is used in a decentralized way so that no single person or group has control. Instead, all of these users will retain control collectively. These blockchains are also immutable, which means that the data entered is irreversible. So these transactions are permanently recorded in the block for everyone to view. So if you have Bitcoin or access to the blockchain network, you also have access to every transaction that has ever occurred because they're all connected through the blockchain. There are a lot of benefits when it comes to comparing blockchain to current monetary methods used, and especially when it comes to cybersecurity. So a couple of these benefits could be that it's almost entirely hack-proof, which I'll go over in the next slide. There's reduced errors because it's being controlled by a computer over a set of networks. There's reduced capital requirements, reduced staffing. There's no more middlemen. The operational costs are significantly reduced. There's also a bunch of potential applications for blockchain. So this can be in the automotive industry, financial services, healthcare, and one of the big ones that's been proposed recently is in the voting system. So this would ensure a very secure way for a national election. It'd make it very tamper-proof, and any claims of fraud would be quickly dispelled because it's so secure. So onto the cybersecurity of blockchain. Blockchain is extremely difficult to hack, and there are multiple reasons for this. One of them is because of these complex cryptographic algorithms, each block's hash contains a large amount of information regarding transactions. So like I mentioned before, the roughly 2,000 transactions that are stored in one block on average, all of those transactions are stored in that 64-digit hexadecimal number. And not only does each block have a single hash, it contains the previous block's hash as well as the timestamp on when it was created. And if any of this information regarding transactions or the public keys of the people performing the transactions, if they're changed in any way, the hash code will also change. And the block's height, so the amount of blocks on the blockchain, has reached around 650,000 as of November 2020. So there are a lot of blocks in the blockchain. Basically, what would have to happen for someone to hack blockchain is they would need to simultaneously control and alter 51% of the blockchain, thereby achieving the majority and becoming the agreed upon chain. Otherwise, when everyone's cross-referencing their copies against each other, which is what these Bitcoin miners are doing, the hacker's version would stand out and be cast away as illegitimate. Not only would they need to control the majority, but they'd have to redo all the blocks because they would then have different timestamps and hash codes because of whatever hack they performed on a specific block. In addition to this, they would somehow have to go unnoticed, as all these network members and miners would notice such drastic alterations in the blockchain. So an attack of this size would require an immense amount of money and resources, and with Bitcoin's growing popularity, this is practically impossible. Rather than attack blockchain directly, these hackers will target methods of storing cryptocurrency. So these cryptocurrencies are stored in different types of wallets, which contain public and private keys. The private keys are basically passwords that initiate the transaction. There are two major types of wallets, hot and cold. So hot wallets have internet connectivity, which makes them more prone to hacks, and these are more used for short-term storage and quick transactions. Cold wallets, on the other hand, are offline, so they're safe from hacks, and these are more for long-term storage. There are two major types of cold wallets: hardware wallets, which are microcontrollers that look like USBs as seen in the top right, and these cost around $100 and are considered the safest type of storage. Paper wallets, on the other hand, are printed QR codes, and these are less popular than hardware because they've grown obsolete over time. There are three major types of hot wallets. The first one is a desktop wallet, which are just software applications that require frequent updating. Mobile wallets are just desktop applications for smartphones, and these are more prone to malware. And web wallets are the least secure options. These can be prone to DDoS attacks, other types of viruses, and they're how the majority of cryptocurrency hacks occur. Over $11 billion worth of cryptocurrencies have been stolen since 2011. So these hackers use a variety of methods when it comes to targeting these wallets. When it comes to mobile applications, this is one of the easier methods. This is because it's pretty common for exploitable errors to be present that will give the hackers access to the public and private keys. They can also gain access through PIN codes, forms of data theft, and unprotected HTTPs. Another medium to go through is desktop applications, and this can be performed through counterfeiting operations, data theft again, and gaining control over the user's system. This can also happen through web terminals, which are the primary way used to steal from hot wallets. There can also be malicious software that will send the users to a third-party website that they thought was legitimate, and there's always possible configuration vulnerabilities. Another medium is through code vulnerabilities, and this can happen through third-party software applications on operating systems. And finally, another one of the most popular ones is phishing or social engineering attacks, which will target individuals specifically. These are a few of the major cryptocurrency hacks that have happened over the past few years. One of them is Coincheck, which is a company in Japan, and this happened in 2018, and they lost around $534 million worth of crypto. This was performed by the North Korean hacking group Lazarus, and these guys are a state-sponsored cyber espionage organization, and they're one of, if not the most dangerous hacking group in the world. They've estimated to have stolen around $2 billion worth of cryptocurrency. On the hack specifically, there's not much info known other than there were some major security lapses and that it was not an inside job. These assets were stored in hot wallets, and the company also lacked multi-signature securities for fund transfers, so it was relatively easy to transfer cryptos between accounts. And the cryptocurrency itself was traceable, but it was traced back to accounts with unknown owners. And there are ways for these hackers to store or exchange the cryptocurrency anonymously. So basically, they got away with it. Another hack that happened was on Binance Exchange, which was in 2019, and they lost around $40 million. This was performed by a variety of techniques, including phishing attacks and viruses. And it was performed with very patient well-orchestrated actions through multiple seemingly independent accounts at the most opportune time. So these guys knew exactly what they were doing. This was, again, the assets were stored in hot wallets and exploited in that way. Another example was on DragonX in 2019, and they lost around $7 million worth of crypto. This was, again, performed by the North Korean Lazarus hackers, and they created a legitimate-looking fake company and convinced the employees to download malware onto their computers through Telegram and LinkedIn messages. So these are the different references that I used, and that concludes my presentation. I hope you learned a lot about blockchain, the cybersecurity of cryptocurrency, and how hackers have been able to overcome some of these obstacles. Thank you.